In example 2, we are going to kind of continue the same process that we did back in section 1, where we're simplifying radical expressions. I'm going to simplify the cube root of 135 x to the 5th. And I showed you one way to simplify radicals like this yesterday, but kind of another way to think about this too is I have a cube root here. I want to think about what perfect cube goes into 135. You might be thinking, perfect cube, what is that? Well, perfect square. So 4 is a perfect square because it's 2 squared. 9 is a perfect square because it's 3 squared. 16 is a perfect square because it's 4 squared. So think about what numbers can we cube. I'll make a list on the side here. Some of our perfect cubes. 2 cubed is 8, so 8 is a perfect cube. 3 cubed is 27, so that's a perfect cube. 4 cubed is 64. 5 cubed is 125. And really those are the main ones that you should know and be able to recognize that they are perfect cubes. So looking at my 135 here, if you take 135 divided by each of these numbers to see if we can find a perfect cube that goes into it, you'll find that 5 times 27 equals 135. So we can cube root 27 and get 3. That 5 we can't cube root, that's going to have to stay under our radical. Then we also have the x to the 5th there. If you think about, if we have the cube root of x to the 5th, how many x's can we bring out? Well, x to the 5th is x cubed times x squared. We can cube root the x cubed part and bring an x out front. But that x squared we can't really do anything with, so that stays underneath our radical. Last thing that we should be thinking about as we kind of go through this problem also is if absolute value is necessary. And as we saw last section, since we have an odd root, we have the cube root here, we won't need our absolute value at all. Our final answer is 3x times the cube root of 5x squared.